Let's also review how substring function is implemented and what this does. So substring is declared here as a function which takes an index, in this version, an index of the character and supposed to return a copy of the string which contains modified version of the substring. So let's take a look at what this function does. So basically our implementation is right here. I'll make it visible. And let's just make sure that everything that this function does in this lengthy expression that we explain what is the behavior here. So we have our original string name hello. Okay, and let's display it one more time as a box representing an object in memory. Internally it contains this string view because it's a sub-object inside the string. Gets constructed as soon as the string is constructed. Okay, so this is what we have so far when we create hello. So hello is this box with another box sitting inside of it, which is a string view object. When we call substring with this parameter 7, this member function of our string is invoked. And we tell this string view object that we want to create a substring. If you read documentation of the string view, its substring version creates a copy of the encapsulated string. Now remember that this object encapsulates a pointer to this original string. So it will substring this function of the string view object will take this original string and will physically create another copy of it, which will only contain this part right here. Okay, so with the word world in it. And so it will return from here, what is returned from here is a copy. Okay, so this returns a copy of the string view. So this is the original O, and this is a copy C. And this copy, of course, now holds pointer to this brand new string right here, which was also copied during this substring. But we have to return a copy of the string because we need to leave our original object unmodified. We would like to continue using it, but use substring, which returns a copy of the string. So you see how we use this construction syntax right here with the string class? So what this does, it creates another string which is populated or constructed around this existing string view. So you see we just made a copy of the entire string with brand new string view object and pointer to brand new substring, new version of this string literal. And this object is returned as a result of the substring. So this substring, this expression hello.substring 7, this returns a copy of this object right here, right? So this object right here is returned here. And of course, now beyond this point, it becomes routine because once again we have this output operator, and now the string and cout are matched against the output operator, and again there is no confusion about any of this operator. The output operator compiles, and we now print the substring version of the string, which contains the word world in it. Okay, so this is just a few things that I wanted to point out before we move on to a real, very interesting challenge in our application because if we continue supporting the functionality of Java-like string in C++, there is now next interesting thing to discover and discuss, of course. I'm jumping back to the header file of our string declaration, and once again I copy and paste from Java documentation, and this is our next challenge. Java string supports concatenation of strings. So basically it says let's take one string and combine it with another string and produce a third string, which is the concatenated version of both of these strings. Basically, the two of them are merged, connected together. Okay, so let's give it a try, and of course this is the signature of this function. Basically we just again copy, we can copy it with the comment right here into the implementation file, and let's add it after the list of our substring implementations. Again, we decorate the name of this brand new function with the scope of string and remove semicolon and align everything and add a body to this function. So let's first think how we could potentially test this. For instance, if we created a second string and name it greeting, okay, and just say hi, for instance, like this. So we could try to concatenate these two strings by using something like hello and concat, which is the name of the new function right here, which is unfinished. I'm just trying to think about its implementation. And using the second string greeting as the one that I want to concatenate with. Basically, I want to be able to take this, add this to it, and return brand new copy of the string. So this is why the return type from this concat function, concatenation function, is also a string. Okay, so with substring we were able to get away with string view substring function, which was able to manufacture everything for us that we need. With this one, I think we will not be able to rely on string view on this occasion, and we're going to have to do a little bit more manual work. And this, when this function is invoked, another reference becomes, of course, the second name for the greeting. And hello, of course, is an object right here. Okay, so this is, I'm just trying my best to draw these 3D boxes. And greeting is another box that we have. And notice that this function concatenate is called for hello. So this function that we call, it's the function for this object. So this concatenation function that we invoke right here gets, once again, gets this parameter to another string object, and this parameter, if this is our input parameter right here, this another, so it will be referring to this second string greeting. So this is hello, this is greeting, this is concatenation function, and its parameter gives us access to another string. So what we I think in terms of what needs to be done to implement this function, we need to first calculate how big the new string should be. Of course, it's the length of this string plus the length of this string plus, I think, also a little character for null terminating string if we want to produce a new string. So we're going to do this manually, and once we produce this new string with 0 terminating character at the end, we can construct a brand new string like this. Okay, and construct it and populate it with these results. So let's do this, and then we will return this brand new string, the third string, from our concatenation function. So in the end, this brand new string will be the result of this right here, and again cout should have no problem using this operator to print the content of our string. Everything from this point will be the same. So let's get started. So I think step number 1, what we can do, let's try to calculate the size of the new string. Okay, so we'll say, let me align this comment. Size of new string should be string view length. So this is the length of hello plus another string view length. So now this is the length of greeting because we get access to it through this reference. That's why we say another string view length. Plus, like I said, we need extra character to accommodate terminating 0. So it's just basically +1. And every time I have to use something like this in my code, I always explain it to myself. I say +1 is needed to accommodate null character at end of new string. Okay, so we need all of this. Now, how do we construct a brand new string? We can calculate the length, and to construct this brand new string, we can simply say new, not meow, new character, we'll use square brackets right here, new char. So new char, new operator, allocates this data type, and we say that we want a block of character of this length. So this will be basically length of this, plus the 0 terminating character at the end. And now we can basically, so what new returns is a pointer to character. Char, let's call it PSTR, like pointer to new string, like this. So we have, at this stage, we should have a pointer to a brand new block of memory, which is the same size as hello world plus hi plus 1. The next step, we can copy, we can use C library copy function stir copy, and we can copy, the destination will be this block of memory. Okay, so this is our block of memory, and we can copy there the content of hello world by asking stir view of hello and using the data function. The data function of string view returns back a pointer to this 0 terminated string. So what we're saying to a string copy, basically we say that go and extract the string from string view and copy to brand new block of memory. So this brand new block of memory, we have a pointer to it, and that's the only place where we remember it. The next step is that we can then copy, all right, we can now copy the second string, which is another string right here, another string, string view data, but we can copy it not at the beginning of the block, but at the position pointer plus stir view, right? Stir view length. Okay, so we can basically copy, append. In other words, first string we copy, copy first string, and then we can name this append second string. Second string. Okay. And once we have this brand new pointer right here, what we can do is, and by the way, string copy appends zero terminating character at the end. So let's make sure that we test it, and then we can revisit the actual pointer manipulation. This is pretty low level, what we do right here. So we'll say string copy, and then we return brand new string, right? So we're just going to wrap the new string around this pointer pstr, right? So we wrap it around just like this, and we return brand new string. So this concatenate call will be able to do all of this: generate new block of memory, copy one string, copy another string, or rather append another string, and then manufacture brand new box, as we discussed earlier, brand new string, and return it from this function. And the result will be brand new string, and we should be able to see the concatenated result. Let's save everything that we have so far and build, just to see if it's all good. Oh, string copy, yes. Well, first of all, for string copy, technically we need to include C string. This is a C string library function. And secondly, it tells me that it's unsafe to use string copy, but I'm going to completely disregard this security warning right now. I'm not going to use anything rather than something very basic. I don't care if it's unsafe. And what I need to do to take care of this secure no warnings, you see I get this secure no warnings. I'll paste this inside my function as a comment. Let's say add this macro to precompiler settings, or precompiler macros, to avoid security errors or warnings. Let's just call them warnings. So notice there's underscore in front of it. So we're going to take this, copy, right? Copy this, and go to project, our project properties. Go to C++ configuration. In fact, I would strongly recommend that you switch to all configurations to make this change, just all of them, and specify it right here. Apparently, I'm sorry, preprocessor, all configuration preprocessor. And here I'll just say edit, and here instead of different options, just copy and paste this. We'll see what happens. Apparently I tried to do some changes there, and now it's just all I need to do is this. So I'm just going to click OK. In preprocessor, so once again, this was project settings, C++ preprocessor definitions, the first thing. just click edit and copy and paste this thing right there, secure no warnings. I strongly recommend that you clean after making changes in the project settings, then build. Okay, so this time it builds fine, and of course it'd be great to see a concatenated string when we print it at the end of our little test. Press Ctrl 5 to run it, and here it is. We just concatenated two strings, hello world, and we also added hi to it. So this is now one string right here. And just before we start this review, just to make sure that everything is properly implemented, another thing I'm going to try is to concatenate string with itself. Hello, hello, printed twice. Let's just make sure that this also looks proper and there's no any kind of issues with that. So this is quite universal, so we have everything is working so far. It looks like it's working fine.